magnetic moment of a magnet. You have to find magnetic moment of a magnet when bent at midpoint. Bent at midpoint. In last class, we discussed about bending in the form of a knot. This is bent at midpoint concept. A magnet is bent at midpoint. How to handle a situation when a magnet is bent at midpoint, we are going to check now. So here in this one, first I am taking one straight magnet. I am taking one straight magnet. This magnet is having the two poles, south pole, north pole as usual. Magnetic moment means we know that it is M, and I can write it as small m into 2L. These all things you are very clear, you know, from my last classes. So now this one, now I am bending at midpoint. So when it is bent at midpoint, what will happen? This is the situation. Suppose this is a north, south. And now here it is making some angle theta. This is making an angle theta at the midpoint. This is a situation simply bent at midpoint. Bent at midpoint application. So here first magnet is having magnetic moment M. Now what is the new magnetic moment? M dash. I think one thing I can say, pole strength is not affected. Pole strength is not affected. Pole strength will remain as small m only. Then what is affected here? Length is affected. Length is affected because length, magnetic length is always taken from shortest path from south pole to north pole, because length is a vector, a direct straight line from south pole to north pole. In this, from here to here, I am taking it as 2L. But here, now, from here to here, it is 2L. From here to here, I have to take it as 2L's. Dash, 2L dash. I can't take 2L because I made into now bent at midpoint means these are two equal parts. Here, what will be the length now? If we made in midpoint, here length is 2L by 2. Here length is 2L by 2. Like that, we made into 2.2 magnets of equal length. That is a cut at midpoint concept, similar to cut at midpoint concept. So here, it is like there is no effect in pole strength, no effect of pole strength. But if you observe the magnetic length, it is affected 2L dash, because always magnetic length is straight line drawn from south pole to north pole, south pole to north pole. This is the new magnetic length 2L dash. If you know the relation between 2L dash and that 2L, then we can get the new magnetic moment M dash. Our target is finding M dash. So to find M dash, we have to get the relation between what and what? 2L dash and 2L. 2L dash and 2L, if you know relation, then you will get the new magnetic moment, that is M dash. Let us check it out. Now, what happened means, when it made into two parts like that, directly I can write, it is bent at midpoint we told. So this one already I told it is the 2L by 2. This is the length I told, and this is 2L by 2. We are very happy in that regard. And if I take one bisector, this is I told that is the, suppose this is north pole and this is south pole I have taken. Now shortest distance, new magnetic length means straight line from here to here. I told this is total is 2L dash. This total is 2L dash means only half will become how much? 2L by 2 from here to here. 2L dash by 2. 2L dash by 2. Because total length is how much? Total length is, total new magnetic length is 2L dash. So only half means here 2L dash by 2. I have drawn one perpendicular here from center, bisector it is. Bisector means total angle is theta. I have given total angle theta between the two parts. So now the angle here I can take it as theta by 2. I can take it as theta by 2. From this diagram, I can now write sine theta by 2 is equal to, what is sine theta by 2? Opposite by hypotenuse. So sine theta by 2, here observe carefully, this is an angle. Total angle is theta. we bisected it is, so theta by 2, and it's a right angle triangle. So sine theta by 2 is nothing but opposite by hypotenuse. Opposite is 2L dash by 2. Hypotenuse is 2L by 2. From that information I am writing here 2L dash by 2 by 2L by 2. If I have written this one, in the both the cases I can cancel 2 and 2. I can cancel 2 and 2. So what I am left with here means 2L dash is equal to 2L into sine of theta by 2. 2L into sine of theta by 2. This is the relation between 2L dash and 2L. 2L dash and 2L. Now we got the relation between 2L dash and 2L. Actually in first page when I am discussing here, you observe carefully here what I told. Capital M dash is small m into 2L dash. Small m is not affected because just bent. Bent means you are not affecting any poles. So pole strength is same. So here what happened? Length is affected. How length is affected? Always magnetic length, straight line between south pole to north pole. As a bent like that. Now the straight line between south pole to north pole length has been changed. The new length I called as 2L dash. Capital M dash equal to small m into 2L dash. Now by taking this one, the angle subtended at center is theta here, and this is a because it made to two parts 2L by 2, 2L by 2. From that information I got here the relation between 2L dash and 2L as 2L dash is equal to 2L into sine of theta by 2. I hope you are clear with this application. Now, what shall we do? Yes, initial magnetic moment is small m into 2L first. Now, the new magnetic moment, small m dash is equal to small m into 2L dash. Just now we discussed that 2L dash is nothing but 2L into sine of theta by 2. 2L into sine of theta by 2. From this information, I can write it as m dash is equal to m into 2L dash as 2L into sine of theta by 2. 2L into sine of theta by 2. But we know small m into 2L. What is small m into 2L? Capital M. When it was straight, the magnetic moment is capital M. So I can write finally my answer is m dash is equal to m into sine of theta by 2. Sine of theta by 2. This is my final formula for new magnetic moment when bent at midpoint. So now what we observe, a straight magnet M is there. It is bent at midpoint. Making an angle theta at the center. Then here south pole, north pole is there here. This is north pole and south pole. Here new magnetic moment is m dash, and relation between them is m dash is equal to m into sine of theta by 2. M into sine of theta by 2. I hope you are clear with this application, how we handle the situation. Let us see here one example. What is that example here? I am taking that. Suppose first a straight magnet, south pole, north pole. Magnetic moment is M. Your magnetic moment I am taking it as capital M, and it is bent right angles. Right angles means between south and north pole, angle is 90 degree. Then what is the new magnetic moment? New magnetic moment is m dash. So now what is the m dash value? We can write m dash is equal to m into sine of theta by 2. This is the formula I have. From this formula I can write m dash is equal to m into sine of theta is 90. So 90 by 2. So I can write m dash is equal to m into sine 90 by 2, sine 45. 1 by root 2. So I can write finally what is the m dash value here? M dash is equal to m by root 2. M dash is equal to m by root 2. This is the formula when we bent at midpoint, right angles to each other. I think you understood how to apply that formula. How to apply that formula. This is small application of applying the formula m dash equal to m into sine of theta by 2. They can bend at 90 degree, they can bend at 30 degree, they can bend at 60 degree. According to the situation of the problem, you have to solve. I hope now you are clear with how to handle the magnetic movement formula when bent at midpoint. Bent at midpoint. Is it clear? So this is one important application. The magnetic moment when bent at midpoint. First magnetic moment is m. Now the magnetic moment is m dash. M dash is nothing but m sine of theta by 2.